Complex rational algebraic expressions can be solved doing a long, laborious process of following order of operations. It also can be solved with a quick technique that you will see here. So we have 3 over x minus 2 over y, all over 2 over x plus 1 over y. So the first thing that we want to look at is how will we get rid of the denominators. So I'm focusing on the denominator within the numerator, the xy here, and the denominator within the denominator, the xy down here. So I want to multiply by a form of 1 to eliminate both of those. So I know I have an x, and I know I have a y. So I'm going to multiply my numerator, this whole thing, by xy. I will also do that to my denominator because that will create a form of 1. And additionally, that will also get rid of the denominator's denominator. So I'm just going to rewrite everything to the right side. As you can see, I have 3 over x minus 2y, 3 over x minus 2y. Now I am distributing this xy to each of those terms. And you will see I am able to cancel. So now I will only be left with a 3y. And again, I'm able to cancel my y's, and I will be only left with a minus 2x. Now let's look at our denominator, 2 over x plus 1 over y. Now again, I'm going to distribute this to both of my denominator terms, and I will be able to cancel the x's. So my denominator is going to just be a 2y. And then I'll cancel my y's, and I'll just have a plus an x. And so I just took this ugly denominator within a denominator, like fraction within a fraction, and I simplified it to create this. So this is somewhat easier than this big mess of fractions within fractions. Here is another example. If I had x over 4 minus 4 over x, all over x minus 4 over 8x. The first thing I want to think about is what will I multiply by? What form of 1 will eliminate my denominators? And by denominators, I mean my 4 over an x and then my 8x. So I mean my denominators within the numerator within the denominator. So what do I need to multiply by to get rid of the numerator's denominators? I have a 4 and an x. So I will need to multiply by a 4 and also by an x. And remember, I'm multiplying by a form of 1, so I'll also do that in my denominator space. But now I ask myself another question. What do I need to multiply by to get rid of the denominator's denominator? And so I am going to need to increase this form of 1, or increase this denominator and this numerator, in order to take care of the fact that I want to cancel out this 8x. So now I have adjusted, and I'm going to multiply my numerator by 8x and my denominator by 8x. So here I've just rewritten it, and I will now distribute to both the numerator and the denominator. So the 2 times 4x, or 8x, will be distributed to here, and then eventually to this term. As you can see, only my 4's will cancel, so you can imagine what this will multiply out to, an x times a 2 times an x. And over here, my x's will cancel, and so I'll have 4 times 2 times a 4. Now I'm going to distribute to my denominator, and everything will cancel out there. So I'll just be left with a nice x minus 4 in the denominator. And so, as you can see, I have 2 times x, 2x squared, minus 4 times 2 times 4, that gives me the 32, all over this x minus 4. Now we're not done. You now need to simplify this rational algebraic expression. And so, first, we're looking at the numerator, and hopefully you will notice that you can pull a GCF out. Now, hopefully you will notice you have x squared minus 16. That is a dots, or a difference of 2 squares. So I expand that, or factor that, into 2 times x minus 4, x plus 4. And now hopefully you're seeing that there is some canceling that can be done. So I get rid of my x minus 4s. And my final answer, my simplified expression, is 2 times x plus 4. Now keep in mind, this all came from this original expression. I agree, there's not necessarily a way that you would know that all of this simplifies to this, and that is why we deal with these complex rational algebraic expressions with this trick of figuring out what do I multiply the big numerator by and the big denominator by that will get rid of my mini denominators, the 4 and the x, and also the 8x. And then I would simplify.